So let's go ahead and take a look at a quick example here. I want to find the inverse, if it exists, of f of x equals square root of x plus 3. Well, I know right away that if I were to simply draw this function, see negative 1, negative 2, negative 3, this function is going to look like this. So I know it's monotonic increasing, so I know the inverse is going to exist. But suppose I didn't know that. Well, what I'm going to do is find d dx of f of x. Well, the first derivative of this is going to be 1 over 2 times the square root of x plus 3. Now, this radical cannot be 0. So in other words, I cannot have x equals negative 3. Well, that makes sense because the derivative has to be undefined at this point. Remember, there's going to be an infinite number of tangent lines. So clearly, it has to be undefined. The derivative has to be undefined at negative 3. But every place else where it's defined, it's going to be positive. This is greater than 0 for all x in the domain not equal to negative 3. Negative 3 is in the domain here, but is outside the domain of the first derivative. So, because it's positive everywhere, then I know that it is, in fact, monotonic increasing, so it's 1 to 1. So I need to find the inverse. Well, there's several steps to go through the inverse, and I'm going to outline what I think is probably the easiest route to go. The first thing I'm going to do is write it as y equals the square root of x plus 3. So I'm going to take my function, whatever it is, and simply say it's y. Second thing I'm going to do is take y and x and exchange them. So I'm going to make x equal to square root of y plus 3. Now I'm simply going to solve for y. So I solve for y, I get x squared equals y plus 3. That implies that y is equal to x squared minus 3. Now my last step, now that I've solved, is I'm going to replace y with the f inverse. So f inverse of x equals x squared minus 3. Now, this x here is a point of contention. And you got to be careful here. You got to understand just what the heck that thing means. Because, yeah, we'll graph it on an xy axis. So, yeah, it makes sense that this x is actually x, but it's not x. This x is really, and this is where the confusion comes from, this x right here is really the y from up here. So if we check this real quick, let's just take f of x. Let's take f of, oh, how about f of 6? F of 6 equals the square root of 6 plus 3. That's the square root of 9. That equals 3. That is y. Now when I put that into the inverse, I'm calling it x, because I typically will graph an inverse function on the xy plane. So I'm actually going to take f inverse of 3. That's my x, which is my original y. Well, f inverse of 3 equals 3 squared minus 3. Oops, that's an ugly 3. That's 9 minus 3. That's 6. That's the original 6, my original x that I put into f to begin with. So that just confirmed that I, at least for this number, when I check my inverse, that the inverse really works. So that makes me think that, yeah, I actually did calculate the inverse correctly.